There you
So
go.
yeah, so I'm looking forward to this. Last time we had you here, you were sort of the beginnings of your spatial journey, and you're going out to tell everyone the good news about spatial. So I'm interested to hear what you've learned and who you talked to over the last year and what your current message is. So let's hear your message, and
Oh,
then I'll bug you after.
all right. So now I swing to full screen, right?
Yeah, or
Oh, no,
yeah, share
slideshow.
screen. That's the one.
You think I didn't do this a dozen times a day, right? Where share screen? Which screen? How about this one?
We can
And I'm just
see
going to
it.
switch it to full. Me too, whatever I'm doing. All right. Are we in business now?
We are in business.
Okay. Well, this is my second post GIS day, and I had to add this. I just added the slide while Wendell was talking because you'll see why in a second. But I talk about infrastructure. It's what I do. I travel the world. I had quite a bit of global travel this year. People are quite interested in infrastructure and how geospatial integrates, and then how we can take that information and apply it to other things we do. Now, let's see if I can get this to move forward. So this is, I'll talk over this while you're reading it because I think it's hysterical. But people always ask me, this is how I feel after listening to the last three talks. I realize that I'm actually what you call an experimental geospatial analyst, not theoretical, just like the physicists divide themselves up between those doing the mathematical models and those telling the story and spreading the word of all the tools. So basically all of this technical stuff people are seeing in the clouds. Charlie Brown sums it up with, well, I was going to say I saw a ducky and a horsey, but I changed my mind. And, when I talk about infrastructure, we all get these things in our mind that we think of. We think of bridges, we think of roads, we think of all these things. And it seems like it's over there. But then when we realize we don't fly above buildings and we don't fly above highways, we're in it. We're like walking among it. We're connecting our Wi-Fi, our broadband, we're working on our computers, we're driving on these roads. And what sometimes we forget is that if you think about the country as a vast network with little nodes here and there. In the cities, we view them as nodes. There are certain points where the infrastructure doesn't serve us, right? There's places where it serves us well. And then we have vulnerabilities. And when you start looking at the city level, the more tools we have at our disposal where we can go and look and be comparative from city to city, which is kind of what I do. I tell stories. Last night we were at the Cooper Union. I'm at Geography 2050, and the questions weren't about the technical tools that we were sharing. It was about, well, how do I tell a story? So I like taking the tools and the technology and reimagining what it might look in a workflow and the types of resources that we have access to when we find ourselves in the role of being a storyteller. And one of the big questions often posed is what comes first, the data set or the story? And a lot of people say, well, I just found this really cool data set and I want to start playing with it. Should I set up a database? Like, how am I going to look at this? Is it Pythonic? Blah, blah, blah. And I say, no, 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 no. It starts with the story. And here's why. The story is what should drive it, because sometimes when we create the story and we create our data question, we have to, obviously, all the time, we have to bring data to the question. And the stories are in the spaces, because when we want to tell a story, but we notice no one's collecting that information and we have a missing data set, that's part of the story, right? That it's a normative process. We call it missing because we expect it to be there. So if it's not there, that in and of itself is part of the story that we want to tell. And really quickly, I packed this deck because I know it's going to live beyond this talk, and I want you to have all the resources that provide the context for the software and the application I'm going to be discussing. But I love the work of Christopher Alexander because he thinks of cities in urban form as a pattern language. And it goes way back to a new theory of urban design. What are the patterns telling us? Instead of making these, formulaic, like Here's a building, here's a road. There's a way, there's a language that the way these patterns interact and can also increase the quality of life of those people interacting. And I think of this through morphometrics. I use a Python package called momepy by Martin Fleischmann. And it's understanding the structure of cities through the lens of data. So we recognize beaks, but I think all of us see right away, none of these are the same. The tool can be used differently depending on what kind of bird you are. Are you eating big nut seeds, the whole bit. So I just kind of want to put that little idea in your mind and then introduce you to Betalina, which you may or may not have heard of. This is really the first time some little caveman scratched on the inside of a cave. Here's what my city looks like. And the unique thing about it for me is it's a city. You can see it. You can see that there's some animal husbandry going up in the upper left corner, and we have a little warrior action on the upper right corner, and animals. There's one animal, I don't know if it's defecating or anything, but that'll be your little Easter egg you have to find in the map of the city. But you can recognize the buildings, the roads, and the networks is the point there. And this is how I'm going to introduce to you global healthy and sustainable city indicators. And this was a big initiative by the Lancet. And those of you who know me know that my beginnings became from healthcare and medicine. And I discovered GIS as a tool to answer a problem I was having. Going through all the EHR data, there was nothing that was predictive. It wasn't the color of people's skin. I don't want to blow anyone's mind. It had a lot to do with the built environment. And so this was a place that I landed looking at this data set, and I'm going to introduce it to you here. There'll be a test on this. No, I'm just, I was motivated just to share the infrastructure here, because when you're telling stories, you can't tell every story at the same time simultaneously. It would be a nightmare and it'd be a hot mess. So when you dig deeper, when you see this, you can kind of see those little areas that are spatial, the areas that intersect, and the kind of stories that we want to tell. And we have a lot of data sets that are just spectacular at integrating this information. And I just threw this up here so you could get a little background on the program, the Healthy and Sustainable Cities. The fact that the Lancet, a medical journal, realized that urban design, transport, and health are very integrated, and we need to have a way to talk about it. And then I just did a little screenshot of some of the spatial indicators that are provided in this data set. And I'm showing you this because this is what's going to be pulled into the SQL database. And, like anything else that's really useful when we come to the table and we want to do things that are geospatial, we have different tools. You can use the GUI, which is something that is right here. There's also Jupyter Lab Notebook. There's other ways to do it. And I just wanted to introduce you to the global healthy and sustainable indicators by showing you that there's more than one way to access the data and to start interacting with it. So you're going to see all of this in the containers that are going to be pulled into Docker, but I want to tell you what it's kind of looking at when we're at the city level. There's a default core, and you can obviously add to this core, but the default core of spatial urban indicators includes population density, urban area, connectivity, the urban network using OSMNX. We're using, OpenStreetMap data. So there's a lot here that many of us are familiar with. And these are the kind of questions we answer. And these kind of infographics are generated or can be generated. But one of the reasons I landed here too is I teach a lot of workshops, and I kind of need that reproducibility algorithm when I'm standing in front of 50 to 100 people, and I have stories to tell, and they have wounds, I have salt. They're just trying to follow along. So I really give a lot of credence to working with Docker and containers. And if you see here, the 5-star guide and GIS practitioners, Docker is a very well-respected container mechanism system to use when you're trying to go over reproducibility, and you have a lot of people gathering that have different resources and different systems. And I'll scroll this on a video in a minute, but I just wanted to show you a close shot and explain that, you download the desktop Docker, you download the software. There's a GitHub link that I'll provide where you kind of step through, and what they give you, and the part that I really appreciated in the workflow is they give you a sample data set, and then they encourage, challenge, make you hallucinate that you could you could do it yourself, but you actually can, because I went in and used Belém, Brazil, to start exploring and to apply some urban morphometrics to. So we'll revisit this. I just kind of blew this out because when you run all this I ran this in my macOS terminal. There's a Python console you can use. You can do it in that GUI I showed you. There's lots of ways of interacting with the data. I am more Pythonic, so I was running it in a notebook. And then, once you kind of edit the data that you're using for the city that you're interested in, after you kind of understand how the process works, this is how you reach success. You start seeing the edges develop and all the things that are unique to your city and your location. And this is just a quick blip look at the containers that build over in Docker. You have the software container, and then you have the PostGIS container, which is the processing and data management portal of this whole thing. And that's why I wanted to include, when I discover a tool or something that I can't, that I'm surprised by, I always feel like other people might find it interesting too. And this is just showing you how you can interrogate and find out what is going on under the hood. It's not a black box. And this is just, I don't know if I was napping when I first started video. This kind of just sits there for a minute. So I'm just going to talk you through. So what happens, if you pick lab and you enter that option in the terminal, it'll make more sense to you when you step through it. This generates a Jupyter notebook for you. And what you see in the markdown area here is kind of that standard directional context they're giving you for Las Palmas, which is their template city. So that if you can get that one to run, you know that all systems are go, and any mistakes that happen when you try to do your own city are your own to figure out. But it'll configure, analyze. I just thought this was brilliant, and it's so clean and easy to render. I'm not going to pretend that it didn't take a bit to get kind of brought up and understand how the system works. But what's so great about an open system like this too is that you can go in there and you can look at the PI files, and you can look at the YAMLs, because basically you're editing the YAML file to be specific to what you are looking for. And the things in the YAML file are those OpenStreetMap. You just have to put the URL. You're not doing anything else more involved than that, except, picking your projection. There are a few questions that you have to answer, because it's going to pull everything from the data resources you provide. And I'll show you the portals, the ones I pulled out after we kind of just see how this runs through. And it just builds it out, and it builds reports that are, almost ready to go. So if you work in city government, if you do anything where you're looking at different cities and you travel, I know that's my currency, is looking at cities, but I'm also talking at Geography 2050 about favelas, and they also retain a certain urban morphology that's interesting to analyze using more traditional packages, looking at unstructured settlements, the same way we look at cities. Those are the tables that are going to be just popular. The data is coming in based on your URL that you provide. I use GeoFabric. This list here if you look on the left where the scroll is, those are all the figures that are going to be generated that can go into reports. This is the actual YAML file. Mine looked like a ransom note. I cleaned it up for purposes of this conversation. The tighter, you just uncomment the areas and the data that you're interested in presenting in your report or in your analysis. You don't have to include everything, but when you do select things, there are certain protocols to make sure that you've defined the right administrative boundary, right? Are you looking at neighborhoods? You can compare rural to urban environments. You can compare different cities to other cities. It's really a dynamic interface, because you know how these databases work. And this is, I didn't clean this one up, but this is like, once I ran that code, this is what I was left with. So you can see how it's telling the story of the area just based on what it can generate from open source data that was fed into it. And then I customized some amenities that, are of interest. Where can you get food, all that kind of stuff. So here's the food, and we're going to go look at this, the graphics in a more detailed way in a few subsequent slides. But you'll see, I just wanted you to see, I was just surprised. I run code all the time, but I'm never able to generate a report and bam. And these configuration parameters here, I show them to you because when you get if you get an error report, you can really decipher the context of what that error report is. What are they asking you? Because you have access to all of this data under the hood. Like I said before, it's not a black box. And a lot of times people will pull in, or often they'll pull in Latin long when we need the meters, and it's just something you forgot, and it'll break your code. But if you can just return to it and fix it, you're back in business. And this is the study region that you see in white. Obviously, this is Belém, Brazil. And then you notice the darker area, the slice, the hashtag area, that's the urban environment that I requested just based on the URL I entered. And this is that data generated, the population grid estimates that allowed me to do a lot of the work. And the pedestrian network edges, OSMNX is a big popular package that a lot of us use. And looking at, the population, because we have the grids, we created the network. Now we can tell you what percentage of the population actually lives within, 500 meters, livable, walkable cities, whatever you want to call them in your analysis of a city. You now have the data entered that can generate it. And now we're looking at neighborhood walkability, because if you study cities, walkability is very important in terms of, a high quality of life, sustainability, health outcomes, all of that is very important. These are ways that we can measure it. There's 25 global cities that are a benchmark, and any analysis you do is compared to those global cities. And then you can look at networks, where all the hubs are, where people pass through. This is fresh food markets. You can see the new nodes. And, a lot of this was done at a 100-meter distance. So there's a lot here to unpack, and you can drive what that discussion is going to look like. A lot of you that work in this sort of data are probably familiar with GeoFabrique. It brings down the files onto your computer. And what I like about this format, the PDF format, is a lot friendlier if you're working, on your local computer. The file size is smaller, and it's more manageable. But and here you have point of interest data, you have land use, there's building data, there's that amenity data I was telling. This is where this software kind of just goes through and pulls these things out, and will put them in the document for you. And I know there's a lot of you that build these sorts of models that just want to get a peek under the hood. And, like I said, there's something there for you as well. And here's the GHSL data sets. There's a bunch of them. I don't think we use these nearly enough, but see, all these live in the database that you generated, in the container, the PostGIS container. This is all being stored in there and then accessed for the processing containers. So you can see there's a lot of interesting work here. The population data, there's the built infrastructure that's looking at more of the buildings and the footprints, things that were released this past year. You can look at land, population, you can go be forward thinking, you can be, pick your year, pick your adventure. But what's important to remember here, these certain specifications have to be entered into that YAML file, because it'll tell you what the projection is and what it has to be. So if you take something that's not meters and you flop it in there, you're not going to get very far. So we all know this, but sometimes in our zeal for solutions, we forget, and then you have to unpack it all. These are how you find urban centers. This is another database that you can pull from that same, the previous page. and start looking at urban centers, and they're already predetermined for you. You find the nearest one and you can use it in your analysis. Like, it's always great to focus on an urban area, but where do the rest of us live, and how are we impacted by these trajectories? And now I just did a quick switch over to QGIS because I'm an open source gal, but I'm sure this can work anywhere else too. But you know how you just go in to the browser and you just set up your server here. But I just wanted to, I made a specific slide for this because if you miss it, it has to be 5433. And if you do this normally, we usually use the port 5432. And you can open up all those folders that were being generated that were in your notebook, and suppose now you have different questions you want to ask and you want to be able to put legs on the other information. You can pull it right into QGIS. You can look inside. This is just what the table looks like. You can also preview it. I just did a quick little snapshot so you can see what the other button does, but you also see how all of this information, not only was it loaded in the Docker container, but it's also loaded over here in your database environment over on QGIS. And then, I had to throw some code in. I did write a book. But like, if you want to reduce it to Brazil, I mean, you could just write the query live, which and you can ask all kinds of complicated questions. I was going to do it live. That's why I left it very, very simple, but we're not doing that now. But you can see just by pulling it, bam, there's a network. I mean, it's instantaneous. Even if you think about the size of this database, it's still very responsive. And you see on the left how that whole thing set up is now full. This is the complete one from running that code that I mentioned to you earlier. This is all of the data we now have access to. And I like using it with SQL inside of QGIS because it's a vast amount of data, and the questions you can ask are ginormous compared to wanting to generate a figure, maybe to put into a report. So, just throwing a polygon in there and taking a look at open spaces and some buildings, you could start getting a feel for an area. This is not obviously production quality, but it shows you how easy it is just to pull stuff onto a canvas, accessing this database. And I wanted to give just a nod to this is that interactive, the GUI, and all the data. If you look on the right as it's scrolling up, that's the kind of data that can be rendered in the GUI as well. So if you want to look at, the total populations, if you want to look at some of the sample points used in the analysis, if you want to really peek under the hood and see how this thing is building out to answer your questions and to create this, I love this. Anytime you can get like a detailed peek, under the screen, and it has a little bit of, you can, if you want OpenStreetMap, if you want the satellite, I feel like I'm playing with the big guys when I have the satellite back there, but sometimes what you need is the OpenStreetMap. And this is the quality of what's generated actually in the Jupyter Lab when you look in your directory that you've created, because that's where you have to load everything in when you download the software. All of these figures will populate for you, and then you can just kind of hover in at a particular location and get the information for that area. And then like I said, you can play around a little bit. And this is what the prettier version of the report looks like. You can still customize this, but I mean, I didn't do anything. I ran the code, made the decisions about the data that was coming in, but this is the end product. And you can go in and add information, take information that's not relevant to your data question. But I think this is beautiful. Carl Hyatt, he's this was his PhD thesis, and he's been extremely accessible and helpful to me for really learning. Once you take something off, the training wheels off, and you're not using the data that created it, it can be a little touchy and problematic. But we figured it out, and I put that stuff into the notebooks so that you don't live it, learn it kind of a thing. But you're looking at street connectivity, the public transport access, all of these resources that are now there for you to access. And, I wanted to close on saying, a lot of people, I realized throwing all that at you, I use a lot of it, and, I write the books. The third one in the middle is on storytelling, but open source solutions for geospatial analysis is a Substack page that I post a lot of these things, like, how do I do it? And, if the questions are general, it's free for you just to, access the software and see how these things are done. And I just wrote a piece about the stories are in the spaces. Don't let the fact that the data might not be available scare you away, because that's part of the story as well. And I always laugh at Locate Press, if you're familiar with them, because all of the people that taught me geospatial have their books here. And I joined the group, and I called it like O'Reilly, Packet, and Locate Press. This was the oatmeal that was just the right temperature. And they offer this code that it'll be in the slides, 30% off any of the ebooks for people attending this conference. And I believe that is me. I'm done.
Never done. Never done. So I've got
okay.
infinity.
I'm pausing.
My question. I'll let you go in a sec, but you've clearly been on a journey. That's one of the things I like about these talks, because every year you've gone like a whole year worth of journey, and you're learning so much new stuff. And I feel like I live in a very static kind of world. I try to learn new things, but it's not like my raison d'etre. As a result, I don't learn as much. And this is like your raison d'etre: learn new things, explain it to the world. So can you like poke down? So you've learned a lot of new software this year. You've learned a lot of new data this year. Like, what is the one like software piece that has made you go whoo? And what is the one like data piece that has made you go whoo?
That was more woo than the other one?
Same woo, just different domain.
Well, the funny story is the software that I showed you, I was all set. I was speaking at SciPy. And so I show up at SciPy, and they're like, oh, you can't do this here. People have private computers, work computers. They're not going to be able to download Docker. And I was like, you could hear that like record scratch. I was like, what? And so I discovered momepy, momepy. You'll see me yammer on about it on the Substack, but it studies urban morphometrics. And it just changed everything when you can look at the urban form and see how it influences the social demographics that layer above it. You realize that maybe we've been focusing on the wrong thing the whole time. And so that really made me pivot and use it as a jumping off point for a lot of the conversations, because my year next year is looking at unstructured settlements across the world and what we retain when these cities develop organically. I'm not talking about slum environments. I'm talking about an unstructured settlement from people that the populations are growing so fast, there's no place for them to live. And I'm focusing on Brazil first quarter. I always have to get a theme when I'm going to be traveling around speaking, because I think it really helps grow the conversation.
And then data. What's the one piece of data that's sort of blown your mind?
You mean like a data set?
Yeah.
I'm not. There's so much I'm trying to figure out. Probably that GHS data, because there's all that building footprint data came out.
Oh yeah.
And some part, you know what I'm talking about? The Microsoft building footprints.
Yeah.
But a lot of it ended up behind a paywall. Otherwise, it was really ugly, and you'd have to do a lot of cleaning. But then I noticed that some places kind of brought it up so you could use it, because you can't really use it unless it has height data and area with it. Otherwise, you're just looking at a bunch of building footprints. Yeah. So that is big with me. Google Earth Engine, the GIS package from Chu Sung Woo, is data that I use nonstop, because it really helps introduce people to these concepts.
Okay, on buildings, I'll give you 2 words: Overture Maps. They're taking the buildings data and processing it. So that's kind of like the best of breed buildings data set these days. And then I want to go back and hit.
Well, it kind of depends, because the part that I like working on is because it's storytelling. People want to hear the stories about what's happening in the world around them. They want to know what's happening in Gaza. They want to know what's happening in these areas impacted by floods and all those things. So, you go into like Maxard, data, and you can go in and use that. So the data, I'll change my answer. The data that I like is the stuff generously released by these huge GIS companies that want everyone to communicate. They want a citizen scientist, and I want people to become citizen scientists so they can learn how to use these tools and start answering these bigger questions.
Awesome. And one last crossover fact: you use Bellum in your talk. Bellum is the site of next year's FOSS4G 2024, the free and open source software for geospatial content.
Did you think that was a coincidence, Paul?
Oh, you got me. Okay. So this.
Well, I was the keynote. at Kosovo last year for FOSS4G.
Oh, so you totally know that.
So yeah, so I want to give Belém some love, because a lot of people are like, and there's another Belém, I forget, is it in Puerto Rico? There's another Belém. I want to make sure that people understand the right one, and they're focused on the right location, and they start to learn about a place that, if they're lucky enough, they'll be able to visit and walk among and learn from.
Okay, so yeah, so mark on the calendar, everybody else, December 2024, FOSS4G. Thank you so much for joining us again, Bonnie. It's been a treat.
It's always fun, Paul. You ask, I come.
Thanks. Okay.